The resonance hybrid is the true representation of the molecule. So whenever we're drawing out resonance structures, we are showing where possible electron density can be, where the electron density can move around, but the true representation of the molecule is going to be a combination of all of the resonance structures, so not just one or another. We get an idea of how much each resonance structure is going to contribute to the hybrid by our ranking that we did in the previous video. But to actually draw out the resonance hybrid, a few things we want to keep in mind. We want to make sure that we're going to be showing partial bonds because this is going to show where all those pi bonds could be in the molecule. And we also want to show partial charges. So where are those charges that are going to show up in the molecule? So for this first molecule that we have been working with, we can go ahead for the resonance hybrid and actually draw out all of the sigma bonds. Because we can't move sigma bonds in resonance structures, we can only move pi electrons, so pi bonds and lone pairs. And so when we draw out all the sigma bonds, what we're going to look at to figure out where we're going to draw in our partial bonds is we're going to see what changes between each of these structures. So for example, in the first structure, we do have a double bond between the carbon and the oxygen, but we don't have it in basically any of the other structures. So that means that that double bond is sometimes there. It's a partial bond, so we're going to draw it as a dashed line. That's how we show partial bonds, is with a dashed line. So that's going to be partially there. What we also see, and so kind of looking to the left of the molecule, we have a single bond here, here, but here there's a partial, there's a double bond, and so that's going to be a partial bond as well, because in all the other structures it's a single bond, but in this one it's a double bond. So we do have to account for sometimes those electrons can move like that and give us a double bond there. So we can draw another partial bond. We take a look at this next bond here, and we see that it's been a single bond in the original structure. It's still a single bond there, it's a single bond there, but we have a double bond here and here in these structures. So that means there's a partial bond in this location as well. Moving on to the bond that comes right after it to see if we have to draw a partial bond here. We do in our original structure have this double bond here. We have it there as well, and here. This structure we do not, so it's a single bond, but because it was in all the other structures, we can draw it as a partial bond. And we're going to do something similar for this next bond down like this. It's a single bond here, single bond here, single bond here, single bond here, double bond in this structure. So yes, that's also a partial bond. And then the very last one, it's a double bond in most of the structures, but in this very last structure, it's only a single bond. And so we do have to account for the fact that it can move, and so we make that a partial bond as well. Another important thing we have to put in is our partial charges. So these ones can maybe be a little bit easier to see. So these partial charges, we have neutral structure in the first one, but in the second one, this oxygen is negative. And actually in all the other structures, it's negative. So that means that some of the time it can be negative. And how we show that is with this delta to represent partial charge, and then we put a minus to say, well, it's a partial negative charge. So that's what we do with that oxygen. Then we're going to take a look at this carbon. We do see that it's positive in this structure. It's neutral in all the others, but because it's positive in this structure, that means it is partially positive. So we can go ahead and put a delta plus down there because a partial positive. We see that the oxygen is positive in this structure, so we do have to put a delta plus over this oxygen as well. And then we can look at the other structures. We see that on this carbon here, we have a fully positive charge. So we don't have that in our other structures on that particular carbon, but because we have it in this structure, we do have to put the delta plus here. And the last charge we haven't dealt with yet is this one on the very end. That's a positive charge on this structure, which means that this is going to be a delta plus at the end of the molecule as well. And that's how we draw out our resonance hybrid. So this one we've put in the partial bonds and we put in the partial charges. And these can be very helpful for when we're talking about reactivity. We do look at these charges to figure out maybe where can reactions take place on this molecule. So in this question, we are actually asked to draw the resonance hybrid for the molecules that we were working with before. I've gone ahead and drawn out the sigma framework here, but if you would like to pause the video and try to do it yourself, then check your answer, that would be great. We're going to start with the partial bond. So we see that in this structure and this structure, we do have a double bond between the carbon and the oxygen up here. We don't have it in this structure, so it's going to be a partial bond. I'm going to draw that dashed line. We also have a bond here that we don't have in these two structures, so that's going to be a partial bond. Down here, we have a double bond we don't have in these two structures, so that's going to be a partial bond. And then we have this bond here in these two structures, but not in the last one, so that's also going to be a partial bond. So basically, we're going to extend that partial bond all the way out to the left bottom carbon. So that's going to be our partial bonds, partial charges. We have the oxygen with a negative, so that's in that structure, not in the other two, so that's going to be a delta minus. We have the negative on this carbon and not any other two, so that's going to be a delta minus, and we have a negative on this carbon as well that is not in the other two, and so that's also going to be a delta minus on our structure. So we said the oxygen, delta minus, this carbon, delta minus, and over here, delta minus. So that's our resonance hybrid. We can put square brackets around this because it is a fully negatively charged molecule, so we can put a negative on the outside of the brackets to indicate that there is a full out negative charge on that molecule. So we can do that. We didn't do that with our the one that we saw in the previous example because of the fact that it was just neutral. For the hybrid for B, what we have already drawn out is that sigma framework. We see that we have the double bond at the top between the top carbon and the right one in these two structures. We don't have that in the last one. There's a single bond here, but we have it as a double bond in the last one, so that's going to be a partial double bond. We have a double bond at this position and not in these two, so that's going to be partial. And then we also have the double bond on this side of the ring and not on this one, so that's also going to be a partial bond. So let's go ahead and put in our partial bonds between these two, here, here, and here. We have to worry about partial charges. Note that we already, because the nitrogen is positive in every single structure, we actually can put a full out positive charge on this nitrogen. So we haven't done a delta plus because that charge does not change in any of our resonance structures. So that's a full out positive there. What does change is the positive on the ring. So we have positive on the top carbon in this structure, the bottom right in this structure, and the bottom left in this one. So that's where we're going to be putting our delta plus because those are the ones that actually move around. So we're going to put them in the places that correspond to where that positive charge shows up. If we wanted to show what kind of a charge this has, we actually have a 2 plus charge because we have two positives on the molecule. So this is not the most stable molecule, but we always will have this formal charge on the nitrogen, and then our delta plus is what moves around because that positive is not always on the same carbon. So that's what we show with our resonance hybrids. We're making sure whenever we're drawing out a resonance hybrid to show the partial bonds, and we're looking to our resonance structures that we've drawn to figure out where those partial bonds were going to be. And then we're also drawing out those partial charges, and we're also looking at our resonance structures to figure out where those partial charges should be.